Hello, this is a short demonstration of an experiment called Spark. Spark enables you to create decoupled React components driven by Sparkle fragments. This approach ensures efficient Sparkle querying while keeping React components modular and declarative. Okay, so when you're building an app on top of Sparkle, normally you would have a central point where you write your queries and you have components scattered all over the place, and you would have prop drilling, and you probably would write a type and convert the Sparkle results into the type. This experiment takes care of that, and not only that, it allows you to declare what properties you need inside the components instead of in a central place. So, how does this look like? We have a React project. This is set up in Vite. Currently, that is the requirement for this experiment. And we start with a main thingy. And inside main, we have a Pokemon list. So let's look into there. And here we see 2 times the use Spark hook. It's also here. And these use Spark hooks, they have types. And we can see the types immediately. We can read the properties, similar here. And what's really cool is that we can write whatever you normally would write inside the Sparkle query in the inner space between the curly brackets. And what's cool is that the type is a combination of all the times where we used the Pokemon subject variable. So we have more places of that. Here's another one, image, and an optional CNO number. So we can look here and we see, oh hey, this is cool. So let's say we want to remove this CNO number, yeah? So we take it out, we save. So first now it's red, we save the thing, and it's still red. So what's going on? Let's see what's going on. So, yeah, somehow the thing didn't work, but now it works again. So there's a compiler in the background, and this compiler, it runs each time. So now we look at the Pokemon type, and it's gone. And we add it again, we save it, and it's back again. Oh, and I know why there was this delay. So it's a delay, it was still working. But there's a delay when you also allow it to fetch the data types for you. Maybe I will make that in a 2-step phase. But as you see, the CNO number has a type, a number, and it might be even undefined. But the number thing, it has been translated from the RDF source. There's a Sparkle query that's been executed on the source, and we find out that it's a number. So yeah, so let's get back on track. So we have a main, we have a Pokemon list. In this one, we grab all the types, and so the types are these things. And then we start to render the thing, and we have a suspense boundary here. And we show the inner list with the states of the query, and we inject those here. So we have a limit, we have an order direction, and we have a extra Sparkle filter query. And so this Sparkle thing, this one is dynamic, and this one is static. So whatever you put into into these quotes, you cannot change that often. You can also not do interpolation there or other things. This must be static, a static string, because that's one part of the trick, how we get this one typed. And so that's how it works. Yeah, so we have a limit, order direction, Sparkle query. You can also set the order field, and that's how it works. On the configuration and installation side, we add the Spark compiler to the Vite configuration. Currently you can only define one source, but at a certain point I will make it possible to have multiple sources, and for each source to define what classes to grab. But you can set the prefixes and you can discover the data types. If you turn this off, everything will be casted as a string, even the numbers. But if this is on, it will do type casting and type discovery. Okay, thanks. That's all.